So here is the first function that we're going to look at. So we're going to talk about how we can simplify it, talk about the excluded values, find the intercepts of it, both the x and the y, and then any of the asymptotes or wholes. So before I start off with these problems, I do like to simplify them. And we know to simplify expressions, we basically want to factor and then cancel anything we can. So looking at this one, I can say I can factor a 4 out. And then that is going to be a 2x minus 3. And then factoring that denominator, I know it's going to be a 3 and a 1. That's going to have to be a 2x and a 2x with a minus and a plus there. So you have to be able to factor these. And any of the factoring methods you've learned can definitely show up when you're looking at these problems. So if I'm looking at this one, I do notice that the 2x minus 3's cancel. And so my simplified expression is 4 over 2x plus 1. So whenever I'm looking to answer these questions, I really do want to keep using the original problem, because the simplified one, while it will have a similar graph, we would be excluding this factor that canceled, so we still always want to look at the original one and kind of think about the original one. So we know the excluded values come from when the denominator is equal to 0. Well, when that denominator is equal to 0, I see we're going to get x is equal to 3/2 and x is equal to negative 1/2. So my excluded values for this one, we can see that x cannot be equal to 3/2 and negative 1/2. Didn't ask us for it, but if we were asked for the domain of this function, the domain of this function would basically be all real numbers except for those two excluded values. Or you could write it in interval notation from negative infinity to negative 1/2, which was skipped over, to then 3/2 to infinity. But that's excluded values. I'm going to go ahead and jump into, because those excluded values are going to be either a vertical asymptote or they can be a whole. What cancels is going to be our whole. So if I'm looking at this one, we can see that 3/2 was the factor that canceled out, so that's going to be my whole. The one that was left over was when x was equal to negative 1/2. Now notice I did leave the whole as 3/2 comma something, because we often want to know exactly where that whole is located at. To find where that whole is located at, this is where the simplified expression is going to come into play. But we are going to plug the location of that whole into the simplified expression. So for this one, to find that y coordinate, we have 4 over 2 times 3/2 plus 1, which is going to be 4 over 4, or just 1. So we know that the whole of this graph is going to be at 3/2 comma 1. Other things that are pretty easy to look at. So y-intercepts, we know that we're going to plug in 0 for x. Plugging in 0 for x, we notice that like all these x terms are going to go away, and that y-intercept is going to become that negative 12 over negative 3. Negative 12 over negative 3 is going to give me positive 4. So the y-intercept over 0 up by 4. X-intercepts are kind of interesting for this one. So we know normally they're going to be set when the numerator is equal to 0. But we looked at the simplified one, like where that x was, it was in the numerator, but it canceled out and was actually a whole. Looking at this simplified expression, there's just a 4. There's no x's there, so there's actually going to be no x-intercepts. And now we want to look at the horizontal asymptotes. So when you're doing your horizontal asymptotes, make sure you're always using the original one. And we want to look at the degree. So I have the degree of the numerator and the degree of the denominator. And the degree is the largest exponent. So the degree of the numerator is a 1. The degree of the denominator is 2. This is a bottom-heavy one, so we know that the horizontal asymptote is going to be 0. So we know it's going to be at y is equal to 0. That also explains why we don't have an x-intercept, because if there's an asymptote there, then it's probably not going to cross the x-axis there. But I will say, disclaimer, we do have some functions that can cross horizontal asymptotes, especially if there's multiple vertical asymptotes, but for the most case, in general, they won't. But I do want to say they can technically cross horizontal asymptotes. They will never cross a vertical asymptote. And so since we do have a horizontal asymptote 0, then we also know there's going to be nothing as to a slant asymptote. So we can put all this information together. If we still didn't know what the graph looked like, we could plug in some easy values for x, like some negatives, some positives. I do want to kind of show us what this graph looks like. I cheated and typed it into Desmos. But here's the graph of this one. I know the whole is not quite showing up because of the way the graph does, but we know technically at 3/2, 1, there is a hole in the graph. So this graph is actually non-existent here. That would be an open circle. But this would be the graph we see. So we see the vertical asymptote was at x is equal to -1/2. We can see that it does not cross that line. We can also see that there is a horizontal asymptote at y is equal to 0, which it doesn't cross. There is an the y-intercept as well is at 0, 4. So we have found all the correct characteristics.